already been completed, and it will now be erased from the list. With this facility, VTrack can produce link node structured data. Buildings are handled in a special way by VTrack. If digitized correctly, we end up with a building that has a point at each vertex and right-angled corners. A less sophisticated system may have approached that building as a contour and incorrectly entered the data. The software is trying to round the corners off because it thinks it's digitizing a contour. This is what could easily happen in a system without VTrack's ability to use the operator's interpretation. Because this is VTrack, the operator can tell the system that this is a building, and VTrack gets the correct result the first time with no further editing whatsoever. Moving down, lastly, to the USGS quad sheet, these buildings are required to have center points and points of orientation. For manual digitizing, that's 2 input steps for each building. But for VTrack, the operator positions the cursor over an area of interest and presses the symbol button. Then all of the buildings within the defined area are captured simultaneously. VTrack has correctly captured a point and an orientation for each building. The software will ignore the road and other features that it recognizes are not buildings. One of the most difficult types of data to capture is the centerline data from cased roads. Here, VTrack works inversely, so instead of following one of the outer lines, it will follow the space between them. In this case, the system will follow a gray line down the center of the 2 black lines. The captured data is shown by the white vector line down the center of the 2 black lines, which is clearly visible here. The white crosses represent junction points, as before. This time, the line has been painted out across the casings, and VTrack can go back to each junction, lock onto it, and continue digitizing. VTrack also has the ability to read and use grayscale data. This has advantages where poor or variable quality maps are to be converted. The system accepts scanned maps in a grayscale form that has 255 levels. On the screen, everything that is colored green represents areas that are available for digitizing. Looking at the top section of the map, VTrack can capture the rail line quite easily. After acceptance, the digitized data is then painted out by the system. This building is in solid green, so it cannot be accurately captured in its current form. In grayscale mode, however, the operator can fine-tune the threshold level to pick up only the building's outline. In tuning the grayscale for the building, the railway lines have turned black, which means they could not have been captured at this threshold level. With other systems, this map might require rescanning at 3 or 4 levels in order to be completely digitized. VTrack's grayscale capability means one-time scanning, even for poor quality maps. In grayscale mode, the operator interface is unchanged with the added flexibility of reading in grayscale data. To verify and/or edit data captured in both AutoPass and interactive mode, we use the VTrack overlay editing system, which also provides for the addition of text and symbols. Here on the screen is shown the urban data. The color represents the vector data, and the black areas represent the raster data. A simple visual check to verify that all the buildings are closed polygons is done by automatically filling them with a color. In this case, we're going to use a red fill. If there were any problems with polygons not being formed correctly, there would be a leakage of color across the screen. But here, there is no leakage and all the buildings are correct. The operator has the ability to turn the raster or vector data on and off independently. Moving on to the utility section of the map, the raster data is of poor quality. The operator uses the grayscale mode to see some of the underlying raster data. The clutter in the background disappears, leaving the data to be captured prominent on the screen. Adding symbols to the map is easily accomplished using VTrack's Symbols box. As I probe this box, you'll see the symbol appear. Then I probe the symbol, Move it across to the position on the map where I wish to place the symbol, place the cursor at the required position, and again, using the button box, press Deposit, which places the symbol. The symbol can be rotated, or made larger or smaller as desired. Again, as I turn off the raster data, you can see the symbol has been placed there. I can pick one of these other symbols and arbitrarily place it on the map, such as the symbol R. These symbols can also snap to a given vector line that has been digitized on VTrack. The export of intelligent vector data from VTrack to the target GIS system is easy. VTrack's many output options provide compatibility with ArcInfo, Intergraph, Siemens, Informap, and many industry and national standard transfer formats. VTrack from LaserScan, combining intelligent interaction between operator and computer with ease of operation to provide the right balance between speed and quality. The most cost-efficient method for capture and edit of intelligent vector data. VTrack from LaserScan.